Hello students, how are you? This is your instructor Muhammad Ali Musawir from UT Lahore New Campus. Today's topic is Pulse Code Modulation. So let's get straight into it. What is it? What is Pulse Code Modulation? Pulse Code Modulation is a method used to digitally represent analog signals. Means we have analog signal and we have to convert this analog signal into digital signal. So its representation, it is known as pulse code modulation. The modulation that we have to use here, this is known as pulse code modulation. We have some main steps of this PCM pulse code modulation. First of all, we have sampling, then quantization, encoding, pulse code modulated output, and then we have the mapping. So what is sampling? Here we have an analog signal. You know what is an analog signal? Means our continuous voice. It is known as analog signal. Here for instance, I have taken this sinusoidal wave as an analog signal. So what is sampling? This is sampling. Sampling means at equal distance, or I can say after equal interval of time, we have to take a value of that wave. Means we have to take the value of amplitude at a specific time, or I can say that after passing equal intervals of time, we have to take the value of the amplitude of that signals. So this is known as sampling. You can see here that we have sampled this analog signal. Means at this interval of time we have our amplitude this one. At this point our amplitude is this one. At this interval our amplitude is this one. Then we have to do the quantization of that sampled input. What is quantization? Let me explain you here. You can see that these were the samples, the dots, the points, and you can see the dots. These were the sampled points, and actually, or I can say approximately, we have to break down the whole amplitude of this analog signal into different points. How? Let's say that first of all you can take here, it is 0, it is 0.2. So it is, I can say this one is approximately 0.2. Okay, this point is approximately 0.2. So I know that here at this interval of time, at this interval, because x-axis is time axis, so at this interval of time my amplitude is approximately 0.2 volts. Okay, so what we have just done here, we have mapped, I can say, we have registered the 0.2 volts as a digital signal, which is 100. Let's take another value. You can take this point, this is what, approximately 0.6. So we have taken the voltage 0.6 and we have mapped it to a digital value of what? Of 110. You know that these are the binary outputs. So quantization is nothing but just taking the instant voltages, amplitudes, and mapping it into a binary code. And you know what does this mean? Let's say if I take 100, so what does this mean? This means that we have a pulse of 1 and then we have two pulses of 00. Okay, let me explain this thing. You can say that here we have 1 and then we have 00. It is just for an example. Okay, so you can say that this one, this is our 1, this is our 1, and this is our 0 point. So if it is 100, I can say that we have 1 volt and 0 volt and then again 0 volt. Okay, so this is how quantization work. So I can say this is the wave, the pulse code modulated output. We have just, you can say, just use the encoding. Okay, like this one, this was encoding to convert these sampled points into a pulse code modulated output. Okay, so I can say where we have, let's take this is one example, 100, where we have 0.2 volts, where we have 0.22 volts, its code is, its binary code is 100. So we will get a wave like this one. It is 1, it is 0, and it is again 0. Okay, so what is this? 1 means a high volt, okay, and 0 means a low volt. So sometimes high volt means 1 volt, sometimes high signal mean 5 volts. So you can say that here we have a high signal and here we have a low signal. You can say here we have a 5 volt, here we have a 0 volt, 0 volt. Okay, and this is its mapping in binary binary modulation. In pulse code modulation, it is from 0 to 1, means here we have a high value, here we have a low value. But in the mapping of the binary section, we have +1 and -1, so that we can perfectly, or I can say we can transmit our signal with as clear messages as we can. So where we have a high signal, we have a positive volt. Where we have a low signal, means a 0, there we will have a negative signal. So we can clearly distinguish our pulses, where we have 1 and where we have 0. So that's why this mapping is important here. Okay, so how we can do this? We can just use MATLAB codes to do this. Okay, so I hope you got all the points about this experiment, where we have to use a MATLAB, and of course MATLAB is just for analysis the graphs. You have to use the ESP, and if you need to, because it is very worth it in digital signals. But this experiment is mainly on MATLAB, because you just have to visualize what exactly happens here when you convert analog signal into digital signal and use pulse code modulation. So this experiment is just based on MATLAB. I hope